Thank you. Hi, everybody. It's great to be here in person. I'm really enjoying this event. As Brian said, I'm a designer by training, and right now I'm doing a lot of study on the impacts of AI on automation in many forms. Things like robots, automation, algorithms that track people and manage workers. I've had a long career as the first design faculty member in a school of computer science. But today I really want to talk about some of my recent research in design and where it's going. Harold Nelson talks about accidental vagrants. These are animals which migrate to climates where they shouldn't be thriving and they thrive. So land birds at sea, for example. All sorts of animals can become accidental vagrants. They serve as creative and innovative solutions for positive change within systems that already exist. So reflecting on my career, I like to think of myself as an accidental vagrant in computer science. So I want to start my talk today with the idea that computing and communication technologies continue to change the world at a rapid pace. We are clearly in the middle of a sea change in technology, starting with the personal computer and now ranging to things like AR, VR, continuous sensing. And there's been a lot of data that's been generated. And people have benefited greatly from these systems, things like information transfer and crowdsourcing, enabling things we could never do. But there's also been shortcomings. For example, hate speech, fake news, and the ability to operationalize on platforms. And you've probably heard this phrase, writers at The Economist decreed that data in this century is what oil was to the previous one. And it's true, data has enabled new economies. Sundar Pichai, the CEO of Google Alphabet, likened AI to electricity, saying it can make humans more productive than anything we've had in the past. But other researchers have warned that instead we should think about AI like fire. Like our ancestors encountered fire. If we control it, we can use it for good, but if we deploy it too quickly and without foresight, we will have AI burning things in ways that we never anticipated. And so today, machine learning and AI affect many, many aspects of what designers touch, ranging from web-based services to conversational UIs and smart products. For example, AI helps judges decide whether criminal defendants should be detained or released while awaiting trial. And AI assists child protection agencies in screening referral cases. And AI helps job employers filter job resumes. And AI enables facial recognition, which can be used for surveillance and crime prevention, among other things. So I asked myself, how are data, machine learning, and AI affecting design today? Well, one helpful construct might be first understanding what we design. Because as technology continues to advance and data becomes more abundant, it's really hard to even understand. So for example, these conversational UIs like Amazon Alexa and Google Home can be thought of as products, but really they're bringing you that service that you engage with your voice. So one litmus test is to think about whether something is bought and owned. If it is, that's a product. Customers purchase products, and there's a value exchange and transfer of ownership when someone does. So businesses get value manufacturing products when they either optimize production, innovate new things, innovate with new technologies, or broaden the suite of offerings. But this too can get confusing because software is a product. So maybe some people in the room remember when we purchased Microsoft Office on DVDs. And these intangible products like software can be pirated and many copies can be made. So it can get really confusing. Services are not the same as products. They're intangible, and they require the presence of the customer and the service provider to exist. So they're created at the time and the place that the service is delivered. So you can think of traditional services like beauty and retail and healthcare, hospitality. But notice there are often many products within a service. So Starbucks is a good canonical example. Starbucks is a service that brings a customized cup of coffee to a person in a place that they desire. The service is the orchestration of taking the order and making this custom drink and delivering it to you. Performance is ubiquity. Anywhere in the world, we can go in a Starbucks and get that drink that we want. And Starbucks is also successfully driving commodities into new areas like airplanes and your home. So the world has already transitioned to this service approach, which we talked about yesterday with James's talk, where we talked about considering all of the stakeholders around an ecology. This New York Times graphic chronicles how our economy shifted from products to services in the last several decades. On the left-hand side, around 1960, you can see that the largest, most profitable companies in the U.S. were product delivery companies like GM and Ford and Sears. But then around 2010, there was a sea change, and the largest, most profitable companies in the U.S. were now service delivery companies like Walmart and Target and McDonald's. And even though these companies are making products, commodities, they use a service framing to make sure that they're developing things that people want. And so service design, I would argue, is really, really critical now for designers. Another helpful construct is the idea that products and services are blending. So product-service ecologies come from efforts towards servitization and productization. Servitization is when we add services to products. So for example, IKEA added home delivery and build services based on customer request. And productization is when we add products to services. So for example, Warby Parker used to be an online-only eyeglass store, but then they added in-person stores to create welcoming customer experiences around trying on glasses. And then we have the construct of datafication or data animation, when data is added to products, resulting in the plethora of smart products that we see. Data can be added to services where AI can play a role in customizing and personalizing what customers need, and data added to product service ecologies where we have whole suites of systems that are supposed to do things like track sleep, help you sleep, etc. So designing with machine learning and AI is different, and I would argue that AI is better than ever. It's the design innovation part that needs improvement. It means that traditional design processes like the double diamond that we teach in school may not apply. The playing field is really different, and some of the research we're doing at CMU shows that we need people at the top to innovate with ML and AI to create products that people will want. We also need engineers who can develop custom models for specific applications. We need developers who will integrate AI in their application development and deploy AI. And we need technicians who will utilize AI and maintain it. And so all of these are needed in product development teams, and they need to have different and complementary skills. So again, I think we're solving the wrong problem. Product development teams working with AI struggle to find the right thing to make. Data scientists can make elegant technical things, but sometimes those aren't the things that customers want. And designers can make things that people desire, but they struggle to grasp AI's capabilities. So some of the work that we're doing at CMU tries to address this gap. So we've been attacking this problem in a number of ways, and I'm going to touch on each of these briefly in my remaining time. First, we conducted field work to understand industry practices for innovating with AI in large enterprise software corporations. We then conducted additional field work to understand how teams who develop AI products think about privacy and account for it in the design process. To help designers understand AI capabilities, we developed a taxonomy of AI based on 40 AI features to help with ideation and innovation. And then finally, in ongoing work at CMU, we're advancing our curriculum to educate future designers for careers working with AI products and services. So I'll touch on each of these really briefly for the rest of my talk. So as I said a few minutes ago, design innovation with AI is a ripe spot for really understanding how we can improve and help designers work with AI. There's been a growing interest in the HCI community in understanding how cross-disciplinary teams collaborate throughout the process of AI innovation. To deepen this effort, we compiled a research team of 22 people. They were academic and industry researchers. Many were working at Accenture on AI-powered enterprise software. We wanted to see how UX and service design unfolded in this group of designers who had experience working with AI products. So our goals for this project were to explore how design-led AI innovation works in enterprise software organizations, to understand how designers envision and identify AI opportunities, and to understand designers' roles on cross-functional teams. We conducted design workshops, we held discussions, we examined the artifacts that they used in their processes, and we reflected on the other tools that they used. Some of the things we learn is that designers invest significant time in understanding AI as described in their design brief. So for example, in this phase, they might struggle with how much AI and how robust the AI should be. So for example, simple AI could be used to remove repetitive tasks, or they could really look at new emerging forms to really change the experience of using the product. Of course, designers have to work closely with data scientists and software engineers, and the goal is to obtain a shared understanding of the intended AI system. Of course, we encountered their barriers to AI innovation. And it wasn't really in working together or ideating or innovating. Sometimes it was the fact that they had to prove these new features as a business case. And when we interviewed people, they grouped these into two types, accelerators and enhancers. Accelerators were the basic AI that would help speed pace or reduce workflow. And enhancers were the much further out innovations that could really improve the experience of work and change the enterprise software in significant ways. And this was difficult for a number of reasons. Teams were expected to focus on MVP. They rarely saw what happened in the later phases of the project. And there, of course, was a lot of uncertainty about data ownership, data availability, and data privacy. So overall, we saw less innovation during the automation or low-level aspects of AI, and more opportunities at the higher levels of AI. And the barriers were actually not in ideation or even the teams collaborating, but in convincing the team that an AI feature was valuable. And really the success comes down to the designer's ability to collaborate well with data scientists. So privacy is one of the most commonly cited human AI design principles, yet how privacy is situated in AI product development is relatively unknown. So we then asked, who advocates for the user in the development of AI products and services? Again, we conducted interviews with 35 AI product developers in a variety of roles. We wanted to discover how they define and situate privacy in their work, how they design for privacy, and what tools and artifacts they rely on in doing this work. So although participants worked across many domains and in a number of roles, they shared an understanding of privacy and a desire to protect their customers when creating consumer-facing AI technologies. They all had an agreed-upon general definition of privacy, but we found that often these definitions don't allow for unique privacy intrusions to really be considered. When talking about specific privacy intrusions around data collection and use, they described barriers like surveillance, identification, excluding customers from seeing their data, secondary uses of data, and general data insecurity. Designers and project managers view privacy as protecting users from data issues, but few of them were able to discuss specific harms, such as intrusive, illegal, or non-consensual data use. We found that many teams primarily follow compliance-centered approaches, and these approaches are carried out because they have to. Therefore, their considerations are usually secondary to other product design goals. They're often rigid, and they're often shaped by management decisions. And oddly, the tools and artifacts that they were using to consider this privacy work really weren't specific to AI at all. They were standard design tools. There were a lot of negotiations in these teams' considerations of privacy. They worked both proactively and reactively. So for example, privacy deliberation might happen during the examination of the design brief in order to minimize privacy risks. One team even brought users in at the point of examining the brief to help identify privacy concerns and considerations. there were a lot of negotiations and trade-offs. Our participants encountered situations in which privacy compliance conflicted with other important design goals. Some described how privacy considerations can limit product functionality. For example, if customer data was deleted to preserve their privacy, it would in the future inhibit the ability to answer questions that customers might have. Other decisions about privacy, like those, were made in a vacuum. Finally, our participants wanted a work culture that helped center privacy during product development, instead of making it be a compliance activity or an afterthought. This culture could, for example, place more emphasis on empathy towards the user when designing for privacy. And it's probably not surprising that most of the free-form privacy considerations were taken on by designers who become custodians for their users. So overall, we found that there was a big mismatch between how privacy is defined and what actions are taken to carry out privacy during product development. We found that a need exists to shift away from a compliance-centered, management-led approach to a more human-centered, practitioner-led approach to privacy. So obviously, tools, methods, and processes are becoming a huge opportunity area in this work. So based on these studies, we decided to take a first step to create a vocabulary around what AI can do for designers. So instead of focusing on how AI works, we are teaching designers about AI capabilities. So designers can then think of AI as a design material. So materials to help with AI-centered design exist from places like Apple and Google, but the capabilities of AI are dispersed throughout these materials. So our goals were to capture abstractions of AI capabilities to support designers during ideation, to focus on the realistic capabilities of AI, reducing the time ideating that things can't be built. We've all seen those statistics that, some huge percentage of AI products fail, and of the ones that make it, even a smaller percentage make it to market. And then to develop a flexible structure so the community could add new capabilities as AI advances. So we started by developing a corpus of AI examples. We selected 40 examples, shown here, to create a draft taxonomy. This work was highly iterative among our team. We chose to focus on commercial products and services rather than research contributions, and we looked across several industrial domains across a wide range of sources. We curated this list into 12 domains, and we conducted web searches for the most popular AI applications within those domains. And then we selected 2 AI features from each domain, resulting in a corpus of 24 features. And we wanted to have high variance and little overlap between these features. Then we broke the AI features into distinct capabilities, as you see in the example here. Our hope was that designers could step through these levels and capabilities to understand how AI worked. So for example, biometric security, shown here, detects a face and an image, then identifies the person based on the face and the image. In this work, we didn't use any specific definition of AI. Instead, we just worked in a bottom-up fashion, accepting results where descriptions of capabilities used the term AI. And so in this way, we could allow for a collective definition to emerge. So as the corpus and taxonomy started reaching a stable state, we started to formalize its documentation and how value was co-created. So on the right, you can see a small excerpt of the taxonomy showing 4 features that break down into 8 actions we identified. So there's a total of 40 features and 202 capabilities, and they aggregate to 8 high-level actions that you can see in the Sankey diagram: detect, identify, estimate, forecast, compare, discover, generate, and act. And then the next step is to make this usable in a form that designers can work with. And we're doing this through our classes and more workshops. So for example, identify could search for a specific item or a class of items among a set or stream. So identify could find a specific person among a set of faces. Detect, on the other hand, requires that an entity be present in order to identify something. So detect could tell if an image contains a cat, while identify could provide the breed of the cat. So these are the kinds of rules and capabilities that we have to try to educate designers with. And we're currently exploring forms to do this. All right, so in the last portion of my talk, I want to back out a little bit and talk about how we advocate for the changes that we need in design education to support these changes in the world. So starting with the Industrial Revolution, the people who designed products were different than the people who created them. And then as interaction and service design evolved as disciplines, designers had more complicated and complex design situations to think through. And ML and AI has only accelerated this. And it continues now with design reaching to broader and broader areas like regulation and public policy. So during the pandemic, when anybody would take a Zoom meeting, I took the opportunity to interview leaders in academia, faculty, department heads and deans, and leaders in industry, design directors, heads of design, chief design officers, and consultants, and ask them about their current conceptions of design and how they think our field should change. So there's a tension between the broader notion of design that's evolving in the world and how it's currently taught in many design schools. People describe design schools as solution schools, focused on training or focused on form giving. They talked about how designers were told to start with problems, not intentions, and courses that were trendy and reflect the interests of students. There was less clarity about what particular design skills are the critical ones and how the academy should emerge. Another pressure that was discussed was online design programs that are changing a lot what is happening in the US. I think the pandemic taught us that we could teach a design studio online. And third, there appears to be less and less importance on a traditional design degree. So I heard, for example, that many technology companies in the Bay Area no longer require a degree for both entry-level and higher-level positions. And they're still struggling to staff with designers, even with high salaries and bonuses. So people generally agree that we need a new view of design which is holistic or systemic, getting designers beyond the first job to a lifelong career. So in recent years, some research has been conducted on the future of design education, such as that of Dunford in 2018 and the work with Don Norman and IBM, which is ongoing. And these high-level efforts are motivated by the reality that designers are facing a world in which they are not trained to design. Some others have done specific audits and made specific recommendations. For example, Institute of Design and the Dubberly Design Studio, which created its own curriculum on the right here, based on the curriculum of HFG Ulm, which is there on the left. And I think an additional step could be to investigate the academic and industrial career paths of designers who are working in this new area and look at the case studies for success and understand what's needed for the future. So these interviews provided clear evidence that a rethinking of institutional and educational goals for design institutions is needed. That there could be a focus on systems design, something we've been talking about since the Berkeley era, that hasn't really delivered. So I've touched on some of the academic efforts in the previous slide, but the other area I think is in professional design organizations. There's an unrecognized opportunity to look at these organizations and see how they might serve communities of design practitioners, researchers, educators, and leaders. A lot of the traditional design communities that we know of are waning. What people want from these organizations is changing, and this is evidenced in the number of groups that are either trying to fold or reform themselves. But I think that some models, the crowdsourced models like Design for America, have been super successful. And I'm not just saying that because Liz is in the room. There's some other really interesting examples. Patrick Whitney is currently a professor in residence at the Harvard School of Public Health. This partnership creates a space for design to impact intractable health problems. IBM's efforts with Don Norman is another example. And these are just two examples of design leaders articulating a new conceptual future for our discipline. But I think we need to lift up more voices and more strong voices to get new partnerships, new organizations, new curricula, and new design knowledge in the world. So in closing, I'll just say the field of design is changing, and it is more than just designing products, services, and systems. It's making a lot of new things and new forms to improve the world. So I hope you can take this up with me, and thanks for listening. And I want to thank my collaborators and students without whom this work could not happen. Thank you.